Hi, welcome. And now we are going to discuss about nonlinear analysis in an Nastran. So, nonlinear analysis is nothing. We are checking the nonlinearity of nonlinear materials. So now I'm opening a component. So this is the one. Actually, this is the component is used on the wipers. And okay, so this is the wiper bush and this is the wiper blade, and this connection has made here. And due to this connection and due to the friction going to be generated on this place, how the material is going to be uh, affect. So this is how we are going to check. This is the way we are going to check it. So now you can see there are a lot of components, and there are a ball and the blade, everything is here. Now I'm taking this component to advanced simulation. I'm taking a new FEM. Here I'm doing one small change. I'm doing idealize, and as well as I'm taking a axisymmetric structural. Since this is a symmetrical component which is similar in the 360 angle, so I'm taking a only one particular phase in the 360 angle. From that phase, I'm taking the result. I'm considering the result of the cylindrical wave. So I'm taking this is axisymmetric, okay, and the axis is. So axis you make sure which axis you are taking. So I'm taking ZX axis. Now I'm creating a mesh collector here. And since it is a 2D axis symmetric, I'm taking a 2D, and here I'm mentioning solid axis symmetric ZX collector, and the material I'm defining, one is for nylon and another one is for steel. Nylon is the rubber material, so I'm naming this as nylon. And another one, the same 2D and solid axis symmetric ZX collector, and that material is steel. Steel. So this is the way I define. Now what I'm doing to make my component into, I'm just activating my uh, idealized part, and I'm promoting the parts I apply. Now what I'm doing, so now I have to trim your body. So trimming in the sense, I say split body. Now I'm going to split my body by using by using Z, not this one, by using XC plane. So this is the plane I'm using for trimming my body, and I'm selecting this, and okay. Now you found the body has been trimmed. Now again I'm selecting trim body. So this time I'm trimming by using Y. Now the bodies are all three bodies. Okay. So here what I'm doing now, I geometrical view. So now I'm entering into my film model. Now my model has been regenerated. Here what I'm doing, I'm switching off unwanted bodies. So now I created my selected bodies. Now what I'm doing, I'm selecting these two surface only, and I'm say show only. Okay. Now you can see this has been created as a 2D surface. Now in the view, you can see these two surfaces. So now this is the way you can create the axis symmetrical component for your analysis. Now I can do meshing. You can go home. So now since I have done the mesh collectors of nylon and steel, I can go with the 2D mesh. Now I can select the mesh, and here so I'm getting problem in the collector. So what I'm doing, I'm creating the collectors again. I'm deleting these both, and I'm creating the physical collectors again. 2D axis symmetric solid ZX collector. uh, so I actually made a big mistake. So what mistake I made now, so whatever I selected is actually I have to keep these two components on the ZX plane only. Don't keep the components on other planes. So I'm switching, I need the first three. So now I need this is the text plane components only, not the other components. So now these two components I can select. I can say show only. Now in the front view, you can see this is a text plane. So now this is the way how to create, not others. So make sure you are selecting your is the text plane, then only you can able to mesh. So I say 2D mesh. Okay. So anyway, I'm doing with the new mesh collector here. Since I'm getting some problem, plain is a text. Sorry for this inconvenience. Mesh collector 2D solid is a text collector. This is nylon and this is steel. I'm unable to mesh here. To Okay, but because the mesh planes are like this, so I'm making silk quad 4. Yeah, so you need to change your mesh type based on the solid, then only it will access. So this is nylon, ZX on ZX surface, apply. So since the mesh sizes are too big, I'm making smaller. Yeah, so what I'm doing, I'm just making a smaller meshes again, some 0.5. And again here this is steel material, made this. Now okay, this is how I made the materials. Now I'm going to boundary condition, so I can proceed to my simulation part. Okay with it, and okay, and here make sure you are selecting axisymmetric structural component, and here non-linear statics. Solution type is 601 or 106 advanced nonlinear statics. And here I'm going to output request. I'm enabling some output request of contact, and I proceed to okay. Okay, now I have done with the settings of my simulation. Now I can go with boundary conditions. Sorry, the first boundary condition, is fixed. Sorry. First boundary condition is fixed constraint. I'm selecting this edge. I'm applying the fixed constraint on that edge. Since this portion is to be fixed with the wiper. And another constraint, user defined constraint I'm defining, that is to be on this edge. Here what I'm doing, that the degree of freedom phi, I'm mm, user defined constraint. I'm selecting nodes, nodes on the point, and here I'm defining free. This is defining fixed. The degree of freedom phi I'm defining as fixed. So I'm just editing. I am getting some problem. Editing some properties here. Okay. Anyway, I want my degree of freedom to be fixed. Remaining and all, I don't bother. So my degree of freedom 3 is to be fixed. And same like, yeah. So now what I'm getting a problem here. What it is now here, I'm uh, getting some problem. So because there is a nodes which I have here, so that node also getting fixed constraint, and that the same node which is getting another constraint for this place. So displacement. So I need to change that one. To change it, and choose resolve constraints. Here, can you see the number one is to be connected with the both. Which constraint I want to apply? So now I'm say SPC constraint. So close. So now you can get no errors, no warnings right now. After that, define some enforced displacement constraint. So here in the enforced displacement, in the degree of freedom tree, I'm applying a field. In that field, I'm going for a tabular constructor. So here I'm defining time dependent load. So this load is going to be very depends upon time. So now here in the interpolation, I'm defining the time row I row one, comma is 0, comma 0, and row 2, comma and 10th second, comma 0 displacement, and row 3, comma and 13th second it is displacement is done with minus 5 m. Wait. So actually I made a mistake. So you should give 0 comma 0, that means and the 0th second it is became 0 and 0, row id will define automatically. So 10th second and there is no displacement, but 13th second there is a displacement of minus 5 mm in the length. So displacement in the sense this node is displacement happening on 13th second up to minus 5 mm. So I applied it, and then this is applied on exactly this node. So after that I'm going to do the region option, so to get the result exactly. So now I'm going to solution 1, I say edit, in the case control. The time step intervals. Creating a time step intervals, number of time step intervals, 30 seconds, and I say OK, and I close it. And I define this time step intervals. So now I need to define the contact between this nylon rubber and this steel. To define the contact between the nylon rubber and steel, so advanced axisymmetric nonlinear contact, and here region 1 I'm defining. This is region 1. It is on top. There is no offset. And the region 2 is, make sure you are selecting this nylon rubber edge, and there is no offset. And here this is the way I designed it. And okay, now there is contact has been generated between the both. Now I can solve the problem. So these are the parameters I need to do for solving this problem. Since as I'm telling you, there is a problem in my software, so I'm having the previous output files. I'm just showing that output. In the result, you will find this is. Now you can see each time interval what happened to the displacement and the all the properties on the particular. Now the contact. Now you can see how the contact here, and 15th second here it is 15 second only it has generated. Now see the displacement here. Actually this is the displacement. So the nonlinear stress has been generated here. Oh my god, sorry, actually I'm getting some problem. The software has been closed. Okay, this is the way you can do the nonlinear contact analysis.